Let's now look at the standard form of a quadratic. Remember we mentioned in the introduction video that the standard form of a quadratic function is just another way of writing the same quadratic function. Standard form of quadratic, you're already familiar with it, I think, and it takes the form f of x is a times x squared plus b times x plus c. There's a lot of good things about the standard form of a quadratic. I'm not going to get too much into it, but the idea of having separate terms for your squared and for your linear term and for your constant is very useful. I'm not going to get too much into it. Just know that when we're in the standard form, what we have is we have separate terms here. We have the x squared term, we have the x to the first term, and then we have what's called the constant term. And so standard form is very useful in a lot of kinds of math. So what we're going to do here is, here's 4 examples, and what I want to do is, all I want to do is identify A, identify B, and identify C, which you're already familiar with. You've already done this before. Okay, so let's look at this first example right here. In this case, A is always the coefficient of the x squared term. And so the coefficient of this x squared term in front of it, well, there's nothing there. Well, remember, if there's nothing there, then it's a 1. So A is equal to positive 1, okay? Now this tells us that A is positive, and therefore this has a minimum, and it is opened up, not opened down. It's opened up because A is positive. This is the same A that you see in vertex form. It's the same one, okay? And then in this case, B is the coefficient of x, which is positive 12. This sign goes with the number, so plus 12 means positive 12. Same thing with C. We have a negative 9 for C, and therefore C is negative 9, okay? On this second example here, we can see that A is 3. It's positive, so it's up like a cup. It opens up, and it has a minimum, okay? B is minus 5, so that's negative 5. So B is going to be equal to negative 5. And then C is plus 7, which means positive 7, okay? 7. All right, and on this third example here, A is negative 2. Now A is negative for this one, and since it's negative, that means it's down. It opens down, and it has a maximum, okay? B is plus 93, so that's positive 93. And C is this third number here, plus 47, which means positive 47, okay? On this last example here, we see there's a negative in front of the x squared, but there's no number there. Well, if there's no number there, it's a 1. So it's a negative and a 1. So A is negative 1, okay? B is, we've got a minus 18, so that means B is negative 18. And C here, we have a minus 40, that means C is negative 40, okay? And that is how we identify A, B, and C in the standard form of a quadratic. Okay, now let's say that we know A, B, and C, and we want to be able to write a function, a quadratic function in standard form, okay? So what we're going to do is we're going to write f of x equals, so basically what we're going to have is we're going to have an x squared term, then we're going to have an x term, and then we're going to have a constant right here, okay? And in front of the x squared is going to be our a term, negative 7. So this is going to be negative 7x squared. And then we have a positive 15 for b, so we're going to put plus 15x. And then c is a positive 4, so we're going to put plus 4. And so we have negative 7x squared plus 15x plus 4. Okay. This next one, f of x is equal to, well, our a is negative 1. We don't have to write the 1. We'll just write the negative, and then the x squared. That's the same thing as writing a negative 1. Okay. Our b is negative 5, so we're going to put a minus 5. Okay. And then put the x. And then our c is positive 81, and so we'll put plus 81. Okay. And then on this third one here, let's see, our a is positive 1. That means we don't have to write the 1 at all. We can just write x squared. Okay. B is negative 13, so we'll write minus 13x. And then C is positive 1, so we'll just put a plus 1 on the end. Okay. And then the last one here has some fractions in it, and that's okay. They're just numbers. Okay. A is 5/7, so we'll write 5 over 7 x squared. Okay. B is positive 2, so we'll put plus 2x. And then C is positive 1/4, so we'll put plus 1/4. And that's okay to have fractions. I know you don't like it. I don't like it either, but it's okay to have fractions in standard form. Okay, the last thing that we're going to do here is we are going to try and answer some questions given standard form. Okay, and here is one example of a function in standard form, and here's another one. We're going to do both of them. But I want you to understand that it's not as easy to find the vertex in standard form. In fact, it's easier to find the axis of symmetry from standard form than the vertex. But with the axis of symmetry, we know that the axis of symmetry is h, so we have half the vertex, and then we can find the rest of the vertex. And here is the formula for the axis of symmetry. It's negative b over 2a. And this is b, 12, and this is a, 2. Okay. Also, the y-intercept is very easy to find in standard form, but the x-intercepts are very difficult. In fact, you already know how to do it. One way to find the x-intercepts from standard form is to use the quadratic formula, which we're not going to do, but I have it down here in the bottom right. We're going to skip doing the x-intercepts because we've already done that before in this class. And we can do it. You could do it with the quadratic formula. All right, so let's start with the axis of symmetry. The axis of symmetry is x is equal to negative b over 2a. So it's negative whatever b is, and in this case, b is 12, so negative 12, over 2 times a. And in this case, a is 2. You can see a is 2, b is 12, okay? And so this is going to be negative 12 over 2 times 2 is 4, and negative 12 divided by 4 is negative 3. So the axis of symmetry is x equals negative 3. And so now we can actually try and find the vertex. The way we find the vertex is we know that it's going to have the negative 3 as the x-coordinate. Okay, so h is negative 3, and now we just got to find k. To find k, we're going to plug negative 3 in for x here and here, okay? And when we do that, here, negative 3 squared is 9. 9 times 2 is 18. Okay, excuse me. 18. And then negative 3 here times 12 is negative 36. So we have 18 minus 36. That's negative 18. And then we have plus 11. Negative 18 plus 11 is going to be negative 7. And so k is going to be negative 7. So what you do is you just plug the number, you plug h in for x into the original function, and the answer is going to be k. All right. So we have the vertex, we have the axis of symmetry. Does this open up or down? Well, a is positive 2 here, right? Okay, so since a is positive 2, this opens, okay, opens up, okay? Which means that it's going to have a minimum, okay? What is the y-intercept? The y-intercept is actually really easy, c. The y-intercept is actually c. Y-intercept is equal to, well, really it's equal to 0, comma c, okay? So in this case, that's 0, comma 11, okay? That's one of the great things about standard form is it gives you the y-intercept right there at the end, okay? So over on this one, the y-intercept is negative 13. It's really easy to see the y-intercept. Now let's identify the minimum over here. And so the minimum is going to be y equals whatever k is, which is negative 7. And then the range, because it has a minimum, it's going to start at negative 7, and it's going to go up to infinity, okay? Now we can do this one over here. We need to first identify the axis of symmetry, which is x equals Negative b over 2a, well, b here is 8. So we're going to do negative 8 over 2 times whatever a is. Well, a is negative 1. And so what we have here is negative 8 over negative 2. Negative 8 divided by negative 2 is positive 4. Okay? And so then the vertex is going to be 4, comma, something. Well, how do we get that number? Well, we're going to go up to the original function. We're going to put 4 in for x, okay, in both places. X is in 2 places here, so we got to put it in both of them. And then 4 squared is 16, but then we have to make it negative. Negative 16. 4 times 8 is 32. So we have negative 16 plus 32, which is positive 16. Positive 16 minus 13 is 3. And therefore, in this case, k is 3. Okay? So the vertex is at 4, 3. Okay? And now does this open up or down? Well, in this case, a is negative 1, so it opens down. That means that it's going to have a maximum. Okay? The y-intercept is at 0, c, 0, comma, and c is negative 13. So it's at 0, negative 13. That's easy enough. And now let's identify the maximum, because we said that it has a maximum. Well, the maximum is going to be at y equals whatever k is, which is 3. So y equals 3 is the maximum. And then the range on a quadratic with a maximum starts at negative infinity and goes up to the maximum, which is 3 with a bracket. And we're all done. We've identified everything except the x-intercept, which you could do with the quadratic formula. But that is how we answer questions using a quadratic in standard form.